The heavens above America have been alight, not in metaphor but in stark reality. Since March 10th, 2026, the United States has been bombarded by an unprecedented number of large fireballs, far exceeding any single month in the past 15 years of recorded observations. This surge is not merely significant, it is astronomical, with the rate standing at 4.5 standard deviations above the norm, a statistical anomaly typically reserved for events of near impossibility. A staggering 79% of these fiery visitors produced ground-shaking impacts. Furthermore, 3 distinct fragments, retrieved from 3 separate landings across 2 continents, all bear the identical uncommon mineral signature. Now here is a crucial detail that the mainstream media has largely overlooked. In the physics of debris streams, smaller fragments invariably precede the main body that generated them, spreading out ahead. What we are currently witnessing may well be the vanguard of such a phenomenon. Please remain with me until the conclusion, as the events that follow this initial wave are the ones that truly matter and have yet to be broadly discussed. Subscribe and stay engaged, as this situation is continuously unfolding. Impacts are still being cataloged, and the data regarding these fragments is still undergoing rigorous processing. When the complete analysis is finalized, this platform will be the first to deliver the findings. You will want to be here for that revelation. Let us delve into the heart of this matter. Something fundamentally altered in the celestial sphere on March 10th, 2026. A change first detected by the data itself, not by sophisticated cameras, inquisitive journalists, or official government pronouncements. The data, specifically the fireball registry maintained by the American Meteor Society, which has been operational without interruption since 2005 and achieved peak efficiency between 2016 and 2018, flagged this anomaly. This is not a nascent system prone to calibration errors. It is a seasoned, thoroughly documented, and meticulously managed archive. In March of 2026, it began to generate metrics that its custodians had never encountered before. Let me provide some context, as these figures warrant careful consideration. Typically, the initial quarter of any given year, spanning January through March, registers between 200 and 400 fireball occurrences within the database. This range has remained remarkably consistent for years, a stability beloved by scientists for establishing a reliable benchmark for comparison. However, during the first quarter of 2026, the AMS documented a total of 460 events. While this number is elevated, its significance is subtly amplified. It is only marginally higher than the 237 events recorded in the same period in 2022. Therefore, on the surface, a casual observer might dismiss this raw count. However, doing so would be a grave miscalculation, as the true narrative lies not in the overall quantity, but in the type of fireballs being observed. This is where the situation becomes peculiar. When examining fireballs with the lowest visibility threshold, those observed by fewer than 50 individuals, the data for 2026 appears almost identical to recent years, presenting a seemingly normal, unremarkable pattern. However, as this threshold is progressively increased, a startling divergence emerges. For events reported by 50 or more witnesses, 2026 has recorded 38 such occurrences. The historical average for this same period is 18, more than double. At 100 or more reports per event, 2026 logged 14 events against a baseline average of 7, again, a doubling. And then, March alone accounted for 5 distinct fireball events that garnered over 200 witness reports. The previous record for an entire March dating back to 2011 was 0. March of 2026 achieved this feat 5 times over. The intensity of the signal escalates with the observational threshold. This particular statement is critical, as it signifies a genuine physical alteration in the incoming cosmic material, not a mere reporting artifact. An increase in camera ubiquity or AI tools expediting witness submissions to the AMS website, nor a viral phenomenon prompting widespread skyward gazes. Such factors would inflate all figures with comparable uniformity. What is evident here is the upper echelon of the distribution dramatically deviating from the rest. The minor events remain unchanged, while the significant ones are experiencing a dramatic surge. There is a specific discernible difference in the larger, brighter, and more energetic end of the observed phenomena. Furthermore, when examining the number of witnesses per event, a new layer of strangeness unfolds. The event on March 8th observed over Western Europe, a slow-moving fireball lasting 6 seconds and visible across France, Germany, Switzerland, Belgium, and the Netherlands, was reported by 3,229 individuals. 3,000 reports for a single meteor event is an unprecedented figure in the prior record. Even setting aside this extraordinary outlier, the remaining events in March 2026 averaged approximately 67 witness reports each. The historical norm hovers closer to half that number. Mike Hankey, the AMS researcher who spearheaded the analysis of this period, articulated it plainly. Almost half of all March 2026 events with 10 or more reports were seen by 50 or more people. The distribution did not broaden. It shifted upward. Do you understand what this signifies from a physical perspective? It indicates that the objects are larger, more luminous, and possess a greater capacity to be observed by a wider audience across extensive geographical areas. Increased size and brightness translate to heightened energy, and elevated energy necessitates an inquiry into its origin. This brings us to the matter of sonic booms, as 30 of the 38 events that surpassed the 50-report threshold in the first quarter of 2026 generated audible booms. That represents 79%. Let that statistic resonate. A sonic boom from a meteor is not a foregone conclusion. It requires an object of considerable size and density to withstand the rigorous atmospheric entry, penetrating the upper atmosphere without merely disintegrating into a brilliant streak of light at an altitude of 100 kilometers. A sonic boom signifies that the object penetrated deeply. A sonic boom indicates a substantial object, and a 79% occurrence rate among the larger events is not a figure that can be attributed to enhanced camera technology. A chatbot cannot conjure an atmospheric shockwave, nor can an AI reporting tool trigger a lightning mapper satellite. Yet the Ohio fireball on March 17th did precisely that. A 7-ton asteroid, approximately 6 feet in diameter, burned with such intensity that a weather satellite captured its flash from orbit. A fragment from the Texas fireball on March 21st pierced the roof of a Houston residence, ricocheting within a bedroom. These are not ethereal apparitions. They are tangible objects possessing mass and momentum, carrying a distinct message embedded within their behavior. That message is this: the data set has undergone a fundamental alteration in its shape, not merely in the numerical values it contains. The very distribution pattern has shifted. The lower spectrum remains consistent while the upper spectrum is exhibiting a dramatic surge. Something distinctly different is entering our atmosphere within the upper size range. And whatever explanation you might consider for this phenomenon, there is one thing you cannot do. you cannot account for it by simply attributing it to more people observing the sky. So what kind of objects are actually arriving? The AMS analysis meticulously charted the direction from which these fireballs originated, a concept astronomers refer to as the radiant, the point in the sky from which an object appears to emanate. Two key observations emerged. Firstly, there is a significant concentration of events originating from a celestial region known as the antihelion sporadic source. The antihelion represents the area of the sky diametrically opposed to the sun. Objects originating from this direction are not descending towards the sun like most sporadic meteors. Rather, they are intercepting Earth from behind as they venture deeper into the inner solar system. Historically, the antihelion has consistently produced some fireballs. In early 2026, activity from this specific celestial sector approximately doubled. Nearly 10 major events have been traced back to a single 1,000-square-degree patch within it. A March 9th fireball, witnessed by 282 individuals along the U.S. eastern seaboard, traces its origin here. Two fireballs, collectively reported 381 times over France on consecutive days, also originate from this region. Secondly, astronomers detected a notable surge in fireballs originating from high declination radiants, indicating rocks traveling on orbits with steep inclinations relative to the flat plane of our solar system. This is an unusual characteristic. When considered in conjunction with the antihelion pattern, it begins to paint a picture that deviates from a clean, predictable annual meteor shower. It appears more chaotic, resembling a structured cloud or a lumpy stream. The question that should now be forming in your mind is, if these fireballs are arriving from disparate celestial directions and share certain physical attributes, size, energy, and the capacity to endure atmospheric entry, what does this imply about their origin? This is where the discussion transitions from a statistical anomaly to something bordering on a profound mystery. And if you found the statistical data perplexing, prepare yourself for what the composition of the celestial fragments reveals. Every meteor shower of which you have ever heard shares a singular characteristic. Whether it is the Perseids gracing our skies each August or the Leonids illuminating November nights, they all radiate from a single point in the sky. Trace any meteor within a shower backward along its apparent trajectory, and all paths converge on the same origin point, the radiant. This occurs because all objects within a defined shower are traversing essentially the same orbital path, established by the same parent comet, intersecting Earth's trajectory within the same predictable temporal window each year. A meteor shower, in essence, is a testament to order, a demonstration of the solar system's meticulous organization. Everything occupies its designated place, adheres to a known schedule, and is explicable by a singular originating event that transpired centuries or millennia ago, leaving a neat trail of breadcrumbs for Earth to navigate annually like clockwork. What is occurring in 2026 does not resemble a meteor shower. While there is indeed a clustering around the antihelion sporadic source, and this pattern is demonstrably real and well documented, here lies the critical distinction. This is not a precisely defined pinpoint radiant. The antihelion is an expansive region of the sky, roughly equivalent to several hundred full moons placed side by side. Sporadic meteors from this direction are observed because it represents a statistically favored zone for near-Earth encounters, as objects follow prograde orbits that happen to intersect our path from behind. It is not indicative of a single ribbon of debris threading through space like a meticulously guarded highway. The antihelion is a general area, a neighborhood, not a specific address. Crucially, the fireballs observed over Germany on March 8th and over Ohio on March 17th, two of the most significant and meticulously documented events within this entire period, did not originate from synchronized orbital vectors. They originated from distinct areas of the sky following unrelated trajectories. According to AMS researcher Mike Hankey, these events are not linked to a singular object or a single origin event. The celestial map does not align. There is no single radiant connecting all the dots into a cohesive picture. So, what does this ultimately signify? It points to the most straightforward explanation: the possibility of a new coherent meteor stream neatly producing all that we are observing has been definitively ruled out. It is no longer a viable hypothesis. What remains is a scenario that is more intricate and, frankly, more intriguing. Either Earth is traversing a diffuse cloud of material comprised of multiple clustered components spread across various orbital families, or there exists a population of debris within near-Earth space that has been disrupted or scattered through gravitational interactions over an extended period, and we are currently encountering a denser pocket of it from multiple angles simultaneously. Both of these possibilities carry significant physical implications, and neither offers a particularly comforting outlook upon prolonged contemplation. Let us revisit the sonic boom rate, as it conveys physical information extending far beyond the spectacle of a brilliant streak of light across the pre-dawn sky. When an object generates a sonic boom, a genuine shockwave that rattles windows, it imparts specific insights into its composition and internal structure, information that visual observation alone cannot provide. Loosely assembled objects, what planetary scientists term rubble piles, essentially gravitationally bound collections of smaller fragments that never fully coalesced into solid rock, tend to disintegrate high in the atmosphere. They encounter the initial layers of increasing atmospheric density at approximately 80 to 100 kilometers in altitude and invariably break apart. This disintegration results in spectacular light shows, occasionally brilliant enough to illuminate an entire hemisphere of the sky, leaving behind minimal trace. No boom, no fragments, no structural damage, only memories and a flurry of excited social media posts. Objects that are more cohesive, denser, and structurally intact, composed of rock that was once part of a geologically differentiated body, behave entirely differently. They endure deeper penetration. They push through the upper atmosphere and into the stratosphere before the mechanical forces of deceleration ultimately overcome their structural integrity, causing them to fracture. This fracturing releases energy explosively, and this explosion propagates outward as a shock wave traveling at the speed of sound, extending hundreds of kilometers across the ground. Windows vibrate, car alarms are triggered, and individuals asleep are awakened, reaching for their phones. On occasion, as residents of a Houston neighborhood discovered on March 21st, the leading fragment penetrates a residential roof and ricochets within a bedroom as if it has a destination. 79% of the significant events within this time frame produce these ground-level shockwaves. 79%. This is not the characteristic profile of a population of rubble piles drifting through the inner solar system on loosely consolidated orbits. This is the profile of something dense, something structurally coherent, something that was once part of a body that itself underwent geological differentiation before fracturing, a body with layers, internal structure, and a history of heat, pressure, and planetary-scale geological processing. The term differentiated carries substantial weight in that description and is about to become even more pivotal, because when researchers analyzed the fragments recovered from 3 separate events across 2 continents, they discovered something that the sonic boom data had already quietly indicated. and it turned out to be the most unsettling data point in this entire narrative. They did not find something unexpected. They found the same something on 3 separate occasions in locations that had absolutely no logical reason to share it. The German bolide on March 8th deposited recoverable material across a field near the German-French border, and these fragments were collected and sent for analysis within days. The Ohio fireball on March 17th left material scattered near Cincinnati, recovered by a team that had been tracking the event's terminal trajectory using infrasound sensor data. The Texas event on March 21st delivered its sample in the most direct manner possible, piercing directly through a residential roof in Houston and landing on a bedroom floor with enough residual heat to leave a scorch mark on the carpet. 3 events, 2 continents, entirely distinct entry trajectories originating from different celestial directions, with no shared orbital geometry that any current model can establish. And all 3 sets of fragments returned from the laboratory with the identical rare mineral classification: HED meteorites, howardite, eucrit, diogenite, a family of igneous meteorites with a very specific, well-understood, and highly informative origin story. Let us dissect this, as it is genuinely significant and the details warrant careful attention. The majority of meteorites you will encounter are chondrites. These are primitive, undifferentiated materials that have essentially remained unchanged since the formation of the early solar system approximately 4.5 billion years ago. Chondrites represent the raw material of planetary formation, embodying the state of the solar system before any celestial body possessed the time or mass to heat up, melt, and reorganize itself into layered structures. They are ancient and ubiquitous, and while scientifically fascinating, they are, in a sense, the default, the background noise of space rocks. HED meteorites are something entirely different. They are crystalline mantle material originating from a body that actually underwent planetary differentiation. This means it accumulated sufficient mass and generated enough internal heat through radioactive decay and gravitational compression to separate into distinct layers. A metal-rich core settling at the center, silicate mantle rock forming above it, and crustal material crystallizing at the surface. This is the process that occurs within actual planets. This is what happened to Earth. And within the asteroid belt, it happened to Vesta. Vesta is the second largest object in the main asteroid belt, approximately 525 kilometers in diameter, and one of the rare asteroids sufficiently large and ancient to have undergone this complete, planet-like geological evolution. It is, in essence, a protoplanet that depleted its raw material before it could achieve the status of a larger entity. And it bears the indelible mark of that interrupted evolution in a scar that is virtually impossible to overstate. A colossal impact crater at its south pole named Rhea Silvia, formed by a collision approximately 1 billion years ago. This impact was so immense that it excavated material from deep within Vesta's interior and propelled it outward across the inner solar system. The objects produced by that ancient impact, collectively known as Vestoids, have been gradually dispersing throughout near-Earth space ever since, slowly spreading across a range of orbital paths due to gravitational interactions with Jupiter and the other planets. For hundreds of millions of years, they have been depositing HED fragments onto Earth at a low, consistent background rate. Therefore, discovering HED meteorites within a recovered meteorite sample is not in itself cause for alarm. It happens. Vesta is a known and prolific source of near-Earth material, and the HED family is well represented in meteorite collections globally. What is not normal, and has not occurred in the recorded meteorite literature in quite this manner, is finding them simultaneously within the same narrow time frame of days. From fireballs that arrived on entirely unrelated trajectories from different celestial regions. These three objects are not fragments of the same single rock. The orbital geometry definitively eliminates that possibility. They approached Earth from different directions. They could not have traveled together. Yet they bear the identical mineralogical fingerprint, the same parent body affiliation, the same ancient geological history, the same billion-year-old crustal origin story inscribed within the mineral structure of the rock itself. Identical fingerprints, yet no shared trajectory, no common flight path, no orbital connection that any current model can establish between them. This represents a contradiction that the data has yet to resolve. And it is precisely this type of contradiction that, in science, points towards something tangible awaiting discovery. A structure, a population, a source that is generating this pattern and has not yet been identified. The fragments are present. Whatever dispatched them is not yet catalogued. And it is within this gap between what is arriving and what has been documented that the remainder of this story resides. When conventional explanations begin to falter one by one, what remains tends to bear a strong resemblance to the truth. And in this instance, what remains is a concept that planetary scientists have studied for decades yet rarely garners media attention: the debris stream. Allow me to explain how a debris stream operates, and I urge you to follow this closely, as the physics involved is what renders the current situation so significant. As a comet or a large asteroid traverses the inner solar system, it sheds material. Comets do this continuously, with the solar wind boiling off gas, dust, and larger chunks as they approach the sun, and these fragments inherit orbits very similar to the parent body's own path. Asteroids shed material through collisions with each other, when rotational forces eject surface material, or when tidal forces during close planetary passes rip chunks loose. In either scenario, the outcome is a trail of debris strung along a shared orbital path, akin to pearls on a string, albeit a string that lengthens and becomes more complex with each subsequent orbit. Now here is the crucial element. Not all fragments within a stream maintain identical velocities. Slight disparities in speed, even minute ones, prompt smaller, lighter pieces to gradually advance, outpacing the larger, more substantial elements. This phenomenon is a direct outcome of orbital mechanics. Over centuries and millennia, what begins as a consolidated mass of debris undergoes sorting by size, with the tiniest particles extending furthest along their orbital path, while larger aggregations lag behind. Consequently, when Earth first encounters a stream of debris, it typically intercepts the smaller fragments initially. The vanguard of the stream comprises those fragments that have traveled furthest ahead. The bulk of the material encompassing the larger objects in denser concentrations, whatever remains gravitationally bound or tightly clustered, arrives later. Consider the data from 2026 through this lens. The meteors that are small, faint, and have low witness counts remain consistent with historical baselines. However, the large, energetic fireballs that produce sonic booms have demonstrably surged. This pattern indicates that while the very small material is behaving normally, the larger material has experienced a significant increase. In a typical debris stream encounter, this divergence would not be anticipated. One would expect all components to increase in unison if simply traversing a more substantial volume of material. However, if one is encountering the leading edge of a stream, specifically the sparse forward section where only the fastest fragments have arrived, then the fine dust that has spread furthest would still be at its background level. while the initial larger, denser bodies that have caught up to this leading edge begin to make their presence known. This constitutes a highly specific and verifiable prediction derived from debris stream physics, and the data from 2026 aligns with it. The Taurid complex serves as the most prominent illustration of this structural type. The Taurids are characterized by a broad, dispersed stream of material associated with Comet Encke, and potentially with a much larger progenitor body that fragmented thousands of years ago. Periodically, Earth passes through a denser accumulation within the Taurids, which researchers refer to as the Taurid resonant swarm, and fireball rates have notably escalated. Both the 2015 and 2022 Taurid seasons exhibited heightened fireball activity consistent with this model. The underlying mechanism is understood, it is reproducible, and it is grounded in physics. However, it is at this juncture that 2026 deviates from this familiar framework. The Taurid swarm has an identified parent body. Comet Encke is catalogued, observed, tracked, and modeled. Its associated stream is mapped, and its trajectory and Earth's intersection points are known. The structure responsible for the 2026 anomaly lacks a confirmed parent body, a designated stream name, or an orbital model that any current catalog identifies as its source. The analysis conducted by the American Meteor Society identified the antihelion region as a significant contributing factor, with a high declination radiant cluster serving as a secondary component. Nevertheless, neither of these constitutes a debris stream in the formal scientific sense. They represent directions in the sky, statistical areas, rather than established thoroughfares with known points of origin. The absence of a discernible parent body is of paramount importance. Consider this. Every effect has a preceding cause. Every fragment that impacts Earth's atmosphere originated from a larger entity. The spectral signature of the HED meteorites points towards the Vesta family, specifically the Vestoids, which are a collection of asteroids originating from a massive impact on the southern pole of the asteroid Vesta in ancient times. The Vestoid family is a recognized entity catalogued and includes several large members currently occupying near-Earth orbits. However, no specific Vestoid has been identified as the source of the surge observed in 2026. No object currently within the relevant orbital configuration has been found that could simultaneously account for both the HED meteorite classification and the observed radiant distribution. The fragments are arriving, yet their origin is conspicuously absent from the record. This is not a minor oversight. It represents a significant void, the magnitude of which is comparable to an asteroid that should be catalogued but is not. From the perspective of planetary defense, there are few scenarios more concerning than detecting the downstream consequences of a large near-Earth object before the object itself has been identified. The fragments serve as an early warning system, but such a system is only effective if the nature of the threat is understood. The selective amplification observed in the larger end of the fireball size distribution is, in fact, the most informative clue within the entire data set. In a natural background population of sporadic meteors, the size distribution adheres to a well-established power law, meaning there are substantially more small objects than large ones, and the ratio between different size categories is predictable. If the total incoming flux were to double, perhaps due to Earth passing through a denser region of the general sporadic background, one would anticipate this power law to remain intact, with all categories roughly doubling. However, this is precisely not what is occurring. The smaller fragments remain at their baseline levels, while the larger ones are experiencing a dramatic increase. This implies a fundamental alteration in the mass distribution of the incoming population. The objects are not merely more numerous at the larger end. They represent a distinct population, disproportionately skewed towards greater mass. Within the framework of a debris stream model, this scenario perfectly aligns with Earth intersecting a segment of the stream where a genuine concentration of larger fragments has aggregated. It is not simply an increase in material, but rather different, heavier and denser material arriving in a localized cluster. Imagine a highway experiencing a rainstorm, where all the precipitation consists of normal small raindrops, and then suddenly golf balls begin to fall. The rain itself has not changed, but the golf balls are a new phenomenon, originating from a specific yet unidentified location. This unknown origin is the crux of the problem. Science progresses through a process of elimination. All conceivable explanations are formulated and then rigorously tested against the available data, with each hypothesis either being substantiated or invalidated. Let us apply this systematic approach here to ascertain what remains tenable. The initial and most widely disseminated explanation in early media reports, to the extent that serious coverage was provided, was the surveillance expansion hypothesis. This posits that an increase in the number of cameras, dash cams, doorbell cameras, all-sky meteor monitors, and fireball reporting applications creates the illusion of more events when in reality the increase is attributable to improved documentation. This is a legitimate concern in any scenario involving anomaly detection within observational systems. The American Meteor Society regards it with seriousness, but it fails to align with the 2026 data for a specific reason. Camera networks capture all phenomena proportionally. If expanded surveillance is artificially inflating the fireball count, it will do so across all brightness levels. Faint events will increase, medium events will increase, and bright events will increase, generally maintaining their relative proportions. What is not observed is a situation where faint events remain static while bright events triple. The surveillance hypothesis predicts uniform inflation, whereas the data indicates selective amplification. Two mutually exclusive outcomes. Camera networks do not produce this effect. The second proposed explanation is seasonal variation, suggesting that certain periods of the year inherently exhibit higher activity due to Earth traversing different regions of the sporadic background. While March does experience some increased activity owing to Earth's orbital geometry at that time of year, this explanation also falters when confronted with the data. Seasonal variations are characterized by gradual, predictable progression, resulting in smooth shifts across the entire distribution. What transpired in March 2026 was abrupt. The spike occurred within the latter half of the month, particularly following March 10th. Seasonal drift does not account for a sudden surge in high-significance events within a 2-week time frame. The calendar does not operate in such a manner. The third explanation addresses reporting bias within the American Meteor Society network itself. This theory suggests that the concentrated density of American Meteor Society camera stations and volunteer observers within the United States creates a geographical distortion, making American skies appear more active than they actually are. This is an interesting proposition and warrants consideration as a methodological point. The American Meteor Society network is indeed denser over the continental United States than in most other parts of the globe. However, herein lies the contradiction. If reporting bias were the driving factor behind the anomaly, one would expect the elevated activity to correlate with camera density, not with the energy of the fireballs. High-energy events, those capable of illuminating multiple states, triggering satellite detections and producing sonic booms that travel hundreds of kilometers, Do not rely on the precise positioning of a single observer station. The Ohio fireball, for instance, was detected by infrasound sensors, weather satellites, and eyewitnesses across 6 states. The German event garnered over 3,000 reports spanning 5 countries. These occurrences would not have remained undetected in the absence of the American Meteor Society network. The reporting bias argument adequately addresses marginal events but fails to account for the extreme outliers. The fourth alternative that warrants discussion, often subtly advanced in certain government-affiliated aerospace circles, involves military activities such as hypersonic test vehicles, high-altitude intercept tests, and orbital re-entry events. The velocities involved immediately render these explanations untenable. The fireballs in question are traveling at atmospheric entry velocities in the range of tens of kilometers per second. The bolide observed on March 9th was estimated to be traveling at approximately 30 kilometers per second upon entering the atmosphere. No human-engineered object returns from orbit at such speeds. The fastest hypersonic vehicles tested as of 2026 reach speeds of approximately 3 kilometers per second. Furthermore, military debris re-entry leaves a distinct spectroscopic signature, characterized by refined metals and manufactured alloys, which is entirely absent from the head meteorites recovered on the ground. The recovered rocks are ancient solar system material, not manufactured objects. Now let us examine the explanation that garnered significant public attention for entirely different reasons. The interstellar connection. In 2023, astronomers identified an object designated Oumuamua, a fast-moving body exhibiting characteristics consistent with an interstellar origin, meaning it appeared to be traversing our solar system from an external source rather than following a closed orbit around the Sun. Interstellar objects are indeed a verifiable phenomenon. The discovery of Oumuamua in 2017 and Borisov in 2019 established that our solar system receives visitors from other stellar systems. Oumuamua further solidified this confirmed category. Consequently, when the 2026 fireball anomaly emerged, a natural speculative leap quickly appeared in online science communities and fringe research circles. The question arose, could Earth have intersected the orbital path previously traversed by Oumuamua? Might interstellar material such as dust or fragments shed during the object's passage through the inner solar system now be intersecting Earth's orbit? This is a genuinely compelling hypothesis, and it is crucial to give it fair consideration rather than dismissing it solely on the grounds of its dramatic implications. What makes this hypothesis intriguing is its timing. If Oumuamua passed through the inner solar system on a specific trajectory, there exists a temporal window of approximately 2 to 3 years during which Earth's orbit could theoretically intersect regions of space previously occupied by the object. The underlying physics is plausible in principle, and the increased energy profile of the 2026 events, the high velocity implied by deep atmospheric penetration, is not inconsistent with material on a hyperbolic or near-hyperbolic trajectory. However, the hypothesis is incomplete due to the mineral signatures. HED meteorites are definitively solar system material, representing the geochemical product of a celestial body that underwent differentiation under conditions characteristic of our solar system. Utilizing elements in solar abundance ratios within a gravitational and thermal environment consistent with formation at 1 to 3 astronomical units from our Sun. If fragments of interstellar provenance were recovered, they would exhibit fundamentally different characteristics, such as anomalous isotopic ratios, unusual elemental abundances and mineral phases not found in any known solar system rock types. The fragments recovered from Ohio, Texas, and Germany do not display any of these anomalies. They are unequivocally native solar system material, originating from an asteroid that formed within our solar system. Therefore, either the interstellar hypothesis is incorrect, or the presence of HED meteorites is coincidental, and the interstellar material has simply not yet been recovered. The former explanation is more parsimonious, though the latter cannot be entirely discounted. Neither conclusion provides a fully satisfying resolution, leading to the kind of epistemic discomfort that often drives individuals towards simpler, more emotionally fulfilling narratives. This is the void into which the internet has readily stepped. The viral alternative theories are worth documenting, not for their evidential weight, but because they reveal a genuine aspect of how human minds react to unexplained patterns. Within 72 hours of the impact event on a Houston rooftop, several prominent social media accounts were disseminating claims that the observed fireball activity represented intercepted probes, objects that had been shot down or deliberately redirected by an unknown entity. Within a week, amateur videos analyzing the flight paths of various events were amassing millions of views, asserting that the trajectories displayed an impossibly consistent geometry that could only be artificial. One account, boasting over 2 million followers, published a thread alleging that a specific geologist involved in the preliminary fragment analysis had gone missing after releasing their findings. In reality, the geologist in question posted a perfectly ordinary photograph taken from a conference in Vienna 4 days later. None of these factual discrepancies serve to quell the narrative. This behavior is not novel. In 1561, a widespread sighting of unusual aerial phenomena over Nuremberg, Germany, likely an atypical atmospheric optical event, was interpreted by witnesses as a celestial battle. The engravings produced at the time depict what observers claim to see: metallic spheres, spinning disks, and crosses. What they were actually witnessing remains a subject of debate among historians and atmospheric scientists. However, their subjective experience was undeniable: a peculiar pattern in the sky, a lack of official explanation, and a cultural framework predisposed to interpret the mystery through its own existing lexicon. In 2026, we possess superior cameras and faster internet connectivity. The interpretive mechanisms, however, operate on fundamentally the same principles. The underlying psychological reality is this: humans are exceptionally adept pattern recognizers, so much so that we often perceive patterns within random noise. When a genuine anomaly emerges in data, a statistically significant unexplained deviation from expectations, the pattern recognition system, which evolved to ensure our survival, fails to differentiate between a true pattern and an inferred one. It actively fills the void, and the chasm in this instance is substantial enough to accommodate entire cosmological frameworks. There is no identified parent body, no confirmed debris stream, no established causal structure. Into this vacuum, every available narrative rushes to occupy the space. The data itself is concrete. The interpretation is where the contention lies. I must proceed with caution in the following section, as what I am about to describe is a hypothesis, an inference based on established physics and observed patterns, not a confirmed prediction. It is important to understand it in this light, yet it is also crucial to consider it because the underlying physics is not speculative. It is standard textbook material. The only element of uncertainty lies in the application of this physics to the current situation. Debris streams are not uniform entities. They are not evenly distributed ribbons of material smoothly laid out along an orbital path, akin to frosting on a cake. Instead, they are irregular, structured, and heterogeneous, the result of complex gravitational interactions occurring over extended periods. The gravitational influence of Jupiter in particular acts as a sculptor of debris stream architecture, trapping material in specific resonant orbital periods and creating concentrated regions known as swarms. The torrid resonant swarm exemplifies this phenomenon, serving as the most thoroughly documented instance. It is a cluster of larger objects embedded within the broader torrid stream, which Earth encounters only during specific orbital alignments. When Earth is situated within this swarm, fireball rates surge. Upon exiting it, they revert to background levels. This swarm is not hypothetical. It has been observed, modeled, and consistently confirmed across multiple transits. Now let us apply the principles governing the internal structure of debris streams to the leading-edge hypothesis. If Earth is currently intersecting the forward portion of a structured stream, a region where the fastest-moving, most significantly dispersed fragments have arrived ahead of the main concentration, then the current activity represents only a fraction of the stream's total contents. By definition, the leading edge is less dense than the core. The largest fragments, those too massive to drift far ahead even over centuries of orbital motion, remain further back within the stream, closer to the original event that generated the debris. An intersection with the leading edge would precisely result in the observed phenomenon: a statistical elevation in the larger end of the size distribution, reflecting the initial arrival of more substantial material, while the overall flux remains moderate, not a full bombardment but a preliminary indication. It is impossible to definitively ascertain whether a denser, more massive portion of the stream lies behind the current activity with the data currently available. The orbital architecture of the source population has not been mapped, and there is no existing model, confirmed stream name, or parent body against which to conduct calculations. What we possess is a pattern within the impact record, a mineral signature pointing towards the Vestoid family, a radiant distribution centered on the antihelion source, and the fundamental physics governing the temporal propagation of debris streams. These elements are consistent with a leading-edge scenario, though they do not constitute proof. Consistency does not equate to proof. However, in the absence of a more fitting model, consistency represents the most robust working hypothesis currently available. What is remarkable about the institutional silence surrounding this matter is not that agencies are withholding information. Let me be clear on that point. But rather that the near-Earth debris environment, particularly concerning small to medium-sized objects, is genuinely undersurveyed. Major planetary defense programs such as NASA's Center for Near-Earth Object Studies, the European Space Agency's Space Situational Awareness Program, the Catalina Sky Survey, and the Panoramic Survey Telescope and Rapid Response System known as PAN-STARRS, excel at detecting and tracking large objects, typically those measuring tens of meters across and larger. These systems have cataloged over 35,000 near-Earth objects, with that number continuously growing. However, the population of objects in the 1 to 10 meter range, large enough to produce significant fireballs, occasionally substantial enough to deliver fragments capable of penetrating rooftops, yet small enough to enter the atmosphere before their presence is detected, is not fully inventoried. This comprehensive cataloging is not feasible with current telescope technology and sky coverage. Objects within this size range are simply too small and too numerous to be comprehensively cataloged. We detect them only when they impact Earth, and we reconstruct the properties of the parent stream from the impact record only after sufficient impacts have occurred. This represents a fundamental asymmetry in the actual practice of planetary defense. We map consequences more rapidly than we map causes. We ascertain what has impacted us before we have identified what is yet to come. In the case of a structured debris stream with an unidentified parent body, the impact record serves as our sole available map. The 3 recovered sets of fragments from Ohio, Texas, and Germany are now, from a scientific standpoint, the most critical terrestrial rocks. Their significance lies not in their intrinsic composition, but in the implications they carry. If the Vestoid connection is further substantiated by subsequent analysis, if additional events in the coming months continue to exhibit HED meteorite characteristics, and if the radiant distribution consistently points back towards the antihelion region's geometry, then the debris stream hypothesis gains considerable traction. Researchers will then be able to retroactively calculate a rough orbital solution, initiating a more thorough search for the parent body. The configuration of what our planet traverses can be systematically charted. This mirrors the established methodology of meteor shower research. We construct a model based on the observed impacts and subsequently endeavor to locate the origin. However, this endeavor is time-consuming and the duration remains an unknown factor. The current ambiguity is not a media misrepresentation. The scientific community has genuinely not yet resolved this matter. The analysis conducted by the AMS, released in early April of the year 2026, acknowledged the unusual occurrence, quantified its statistical significance, and identified the concentrations of antihelion and high declination as noteworthy. It did not assert the existence of a debris trail, nor did it identify a progenitor object. In the precise language befitting responsible scientific inquiry, the report stated that the observed pattern was atypical, that conventional explanations were inadequate, and that continued observation was warranted. This represents the current state of our understanding. Further observation necessitates the passage of more time. As this additional time elapses, a greater quantity of whatever is responsible for this phenomenon will be encountered. Therefore, this is our present predicament. There is a statistically documented anomaly within the record of fireballs, exceeding the anticipated rate for large energetic events by 4.5 standard deviations. A mineralogical signature connects several disparate incidents to a single asteroid family. However, no definitive parent body has been identified, no specific stream has been named, and no orbital model currently explains the complete pattern. While competing hypotheses exist, none fully encompass all the variables involved. Furthermore, there are well-established and undisputed physical principles that precisely describe how a debris stream disseminates its constituent elements over extended periods, with the smallest particles arriving first and the largest last. The vanguard of the stream precedes its core by years, decades, or even centuries, contingent upon the stream's age and internal composition. Every meteor shower you have ever witnessed is the consequence of a cataclysmic event, such as the fragmentation of a comet, a collision between asteroids, or a planetary interaction that liberated material and propelled it into shared space. The Perseids exist due to Comet Swift-Tuttle shedding its outer layers during each orbital pass. The Leonids exhibit intensified activity every 33 years because the stream possesses a dense core through which Earth periodically travels. The Quadrantids are traceable to an object that may no longer exist as a singular entity, perhaps a comet or asteroid that disintegrated, leaving only its stream as evidence of its former substance. Each stream represents a narrative of destruction, a spectral echo of a past event. And each time our planet traverses such a stream, we decipher a segment of that story through light and sound, and on occasion through tangible fragments impacting the ground. It is possible that what we are currently observing is the initial phase of a narrative whose complete extent is not yet discernible. Physics dictates that the smaller fragments arrive first. Historical precedent suggests that streams have an origin, and scientific inquiry posits that this origin is still situated somewhere between the current impact data and the void where a progenitor body has yet to be identified. Within a debris stream, the initial arrivals are the smallest particles. The ultimate arrivals are the objects from which these fragments originated. In every documented instance, the initial phenomenon observed consists of the smallest fragments. The ultimate revelation pertains to the source from which they were dislodged. We are presently in the initial phase of this unfolding scenario. The available data is conveying a message. The critical question is whether we are posing the correct inquiries before the latter part of this event materializes.